Hi there, fellow experimenter. My name is John. This lab will attempt to model the spring mass system where the mass swings in an arc while oscillating. This models the final moments of the motion of a maniac jumper in his elastic rope descent. The roadmap of the lab is shown in this slide. The energy principle and momentum principle will be used to investigate the object's behavior from both the motion and energy perspectives. The energy principle states that the energy change in a system is equal to the work done by the surroundings. Our system will include the Earth, as can be seen from the diagram with the spring and an attached mass. The expanded energy equation is shown here. The final energy equation does not include any kinetic energy of the Earth, as these are negligible. The momentum principle has been addressed in prior labs and will not be addressed here, although it is crucially used in the object's motion. The spring model has the following characteristics. L0 is the relaxed length of the spring when it has no force applied to it. The constant Ks is the spring constant or spring stiffness and is a characteristic of the spring. It is a positive number, and the higher the value, the more force is required to stretch the spring. L is the length of the stretched or compressed spring. The force is always in the direction so as to restore the spring to its relaxed length. L hat is a unit vector in the direction of the vector L, and hence the vector. The motion of the spring mass had been pre-recorded by the course staff. The track of the spring mass was recorded by myself. The XY axis are as shown, with the origin at this point. The positive Y axis in this direction and the positive X axis in this direction. The calibration stick was 0.70 of a meter and is indicated here. The physical details of the experiment are given in this slide and were extracted from the recorded tracker data. Of particular note is the calculation of the spring stiffness Ks and the spring relaxed length. Both are calculated from the tracker data. The stiffness is calculated from the period of the Y motion here, and the relaxed length based on the equilibrium position under the influence of gravity. We will now look at how the physics are modeled in VPython. The VPython program has the following broad sections seen in this slide. There are three graphs to be shown. The first visualizing the motion of the track data and its predicted motion, the second plotting the energies involved, and the third predicted and actual plots in the y-axis. Notice the graphs are simultaneously plotted. Tracker data is now entered into the Python script with all the constants previously described. The following VPython configures the iterative part of the code that computes the spring position and energies. L hat is a direction vector that is used to specify the spring force vector. The main loop calculates the incremental change in kinetic and potential energies of the ball and the potential energy of the string. The loop also computes predicted positions for the ball. The momentum principle, Newton's second law, is used to predict the velocity based on the forces due to gravity and the spring force. This may be seen here. From this calculation, the new ball and spring position can be calculated. There we see it here. Finally, position and energy changes may be plotted. Finally, let's run the program. The resulting display window shows the difference in Y coordinate and the observed tracker data. Of course, for concern is the difference at the minimum end of Y coordinate. This is as much as 5 centimeters out. Perhaps my tracker observations were not accurately made, or the origin was misplaced. The energy window shows the changes in both kinetic and internal energies. The spring and gravitational potential energies fluctuate between positive and negative values. It can be seen that the total change in energy, the yellow line, is 0, verifying the energy principle. The periods in X and Y were calculated from the observed data as shown. They are different. The vertical motion period is due to spring motion. The horizontal motion period is possibly due to simple harmonic motion or pendulum type motion. I am not sure.